The tasks involved in preparing, barbecuing and serving a meal of hamburgers are given in the precedence table. This table doesn't only give us the task, but it also gives us the time in minutes that each task requires to prepare. Once we have drawn the precedence table, we can identify the critical path, and we can also find the minimum completion time. I have already done a video on drawing a precedence network for 2 different tables. If you like to watch them, go to my channel and you can find it there. I'll put the link on the end of this video. To start off, let's examine the prerequisite column. These 2 slashes mean that this is where we start. Since event A does not need a prerequisite and B does not need a prerequisite either. We could give ourselves a note and write start here because this is where we start, and we can also start from D. Now we notice that we have B and C together, and that means that these 2 tasks must be done before we attempt to do task D. So it will look like this usually, where it comes to a point, and this is B and C before we can do task D. The same thing will go for D and D. We must do D and E first before we start doing task F. And so we start drawing our table with start. And from this start, we have 2 events that can happen, A and B. A is where we gather the ingredients. B is where we preheat the barbecue. Now we're told that before we mix and shape the hamburgers, we had to do A, which was gather the ingredients. So our task C is done after we gather the ingredients A. Now we come to the next task, which is to do task D. Task D, cooking the hamburgers, can only happen when B and C have been done. So we must be prepared to join task B with task C before we start cooking the hamburgers. And therefore we need to redraw the line structure so that task B joins task C, and here we can now proceed to cook the hamburgers. Now to prepare the salad and the rolls, all we had to do is to gather the ingredients. So we can proceed to prepare the salad and rolls straight after A, which means that all I need to do is start an arrow from A. But I also note that D and E must be completed before I get to task F. So I'll need to redraw this arrow E to join with the D here. And now we're ready to assemble the hamburgers and serve them. And this is the end. To identify the critical path, we must assign the time in minutes to each task. A took 5 minutes to do, B took 10 minutes to do, C took 8, D took 12. You can see that the length of the arrows does not represent the length of the time it took to do the task. E took 10 and F took 4. And so the critical path is the longest path through the precedence network from start to finish. So let's start from A here, and let's go through A, and then we'll go to E, and then we'll finish off with F. If we take this path, it will take us 5 minutes plus 10 minutes plus 4 minutes, which ends up being 19 minutes. Let's look at another path, and let's look at the path that goes straight from A, C, D, and F. This path will take 5 plus 8 minutes plus 12 12 minutes plus 4 minutes, and that will be 29 minutes. Could take one more path, and that's going from here, B, D, and F. And this path will take 10 plus 12 plus 4, which is 26 minutes. And as you can see, the path which is the longest path for this precedence network is called the critical path, and therefore it will be the path with 29 minutes. And this also gives us the minimum completion time for the project, which is 29 minutes. As I said before, there was another video that I made for the Precedence Network, and I'll attach this over here so that you can have a look at it. Also, if you find this useful, please like it and subscribe to this channel.